Hi, this is a comparison of 4 methods to predict coronavirus. The 4 models are rolling median, rolling average, AR, which is autoregression, and Fibonacci weighted rolling average. I'm not going to explain the Python code for these, for none of them except the AR model, which is this one. So this requires linear algebra. Y11 is np.1s all over the place. Is a coordinates of n minus 1, 1. Higher range n, so we'll do it 7 times. Y1 equals y 1 plus I to n plus I. That cuts the bits out. What I want to what I want. Y12 equals y from 0 to n minus 1. Y13 is np dot reshape, which means change the shape from 0 from 0 to n minus 1 to n minus 1, 1. And a matrix is np.hstack, which means stack them together, y11, y13, which is why we do reshape here. Otherwise you can't do that. Inverse is np.linear algebra.Penrose inverse. And that inverse is a matrix bit. Coefficient is np.matrix multiplication. Inverse, y1. Y prediction is matrix dot, which means multiply them. Dot multiplication them. And then y prediction 1 equals y predict n minus 2, or y equals np dot h stack. Y, np dot round. This bit, which is a renewed y. So that's why we have y org is y original. Okay, so I'm not going to explain any other bits. If you want to know, just go to my last videos, because my previous videos explain the code. Now, to get the picture out, so I'm going to shut that down, and then as I get the pictures out, and then so for the top left, this is rollers or moving, however you want to call it, median. So the black bar and the yellow line for all of them is the original data. The red line for this one is the red bar for this one is the prediction, and then the blue line is a fitted. Well, what I'm talking about is this bit, what I get when I put the original data fitted in there. This applies for this and this, because for moving median and, or however you want to call it, rolling median, and this rolling average, moving average, whatever you want to call it. And these two are different. As you can see, this is the fitting of the curve. This is weighted moving or rolling average. Because it's weighted, you're going to see all these periodic outliers still there, so you can't remove them using this. But here and here, it doesn't even have blue lines. Well, really it does if you look at them closely. but still very hidden because it doesn't. Because the blue light uses all the original data to predict, so it uses the past, and that's it. I will now compare this because that's all this video is about, and this uses median, and it takes the median of 7 consecutive values of each day to get this result. And yeah. After this, we have, and this, they are accurate at the different times. So now, this doesn't really look like it's going to be accurate because I seem to find a trend like going down, and I don't think that's accurate right now. Well, it was accurate here, but currently not now. So no. Here for the rolling average, for top right, this is weighted rolling average. So it takes, so it's in 7 consecutive days. We have let's say today was this, and 7 days before, and then the result is the yesterday's data, which is weighted using Fibonacci, and which is weighted more, and then wait. Well, yeah, you can see here. Yeah, and and you made me think I still haven't posted the code of that. Well, I think you don't need to know. Anyway, no, that's why they have the periodic outliers here, going down, and then it seems to go flat here, which seems like it's an accurate prediction, but unfortunately they all predict what seems like they all probably looks like they're off by a bit. And then now the rolling average, it seems like this is most accurate now, because human predicts that it goes down and then goes up again, but not like this time scale. Well, yeah. So the most accurate are this and this, and then this, it predicts that rolling average, and then what it is a continuation of the rolling average, and then that's it for this, and then finally this is continuation. Finally, this is the AR, and then because the blue line is hidden under the yellow, it uses all the original data to do this. So why it's hidden, and then compare all of them. So I'm going to compare. So against this, it's just going to against the median. It just predicts all 7 of these. So against that, this isn't why I had a day that predicted almost exactly for the first day, but then it wasn't really good. Those are all 7-day predictions, and then this, unfortunately, this against this. Well, the pro for this is that it had an accurate prediction before, so it is good. Only they're best at different times, so I have to use different prediction methods to do this. The second is also, yeah, it's good. Well, the pro of this is that it cuts out all of the outliers the best. So what I'm talking about is this is an outlier. So compare that with the average, because it affects the curve a bit. And this, which is why this is the best at cutting out outliers. So let's say we have a set of numbers like 1, 2, 3. If I take the median now, it's 2. If I take the average, it's 2. But if someone mistypes this 1, 2, and then it typed 33, that the median is still 2, but average is going to change significantly. Like, really. The average will now be 12. So median is best at cutting out outliers and ignoring them, so they're totally excluded. And this isn't good at cutting out outliers because they predict that this, down, all this. They still have outliers present there. So, nope. So, yeah. But I did predict, but they seem to predict the same thing, almost the same thing again and again. Like this prediction is as good, is almost predicts like this. So, yeah. And so they seem to have similar results. For the third one, I have this rolling average, which, unlike the median, it could still affect, like I said before, it affects the curve a bit, but you can see clearly we're on the downward trend. Because, yeah, like down here, where the deaths have not been reported, truly there are actually more deaths like here. So, yeah. And then the prediction bit is here, wavy, which to me seems like the most accurate, because Tuesday, Wednesday, and then Thursday, Friday, Saturday, Sunday, Monday, and then on Thursday I go to predict lower deaths. So it also predicts lower deaths. So I go with this prediction currently. But against this, it doesn't cut out outliers like the median, as I said before. And then the AR, which I like all these. It uses all of the original data, no changes to it, to predict these, which may look like the same, but are actually higher predictions. Yeah. So what these numbers you might be talking about 431, 403, 411, 431, 463, 440, and what looks like around 429, around that. So yeah, that's great. Now those are the, and then this, it just predicts the last day, all of it. Like, what? And then the same with this. But this is a bit higher. It's around 600, which I don't see that as accurate. Well, but it may be. So, a pro is that this is accurate enough. And then I have finished comparing. So it seems like the rolling average method is most accurate now. So that's it for the comparing, and then the summary. And then out of all of these, I find that the rolling average is most accurate, and then the second most accurate is AR. So those are the best two right now. And then to sum up, I use these models at different times, and they predict accurately at different times. So I can't use only one model to predict. I have to use all four of them. So, and that's it for this video. So please subscribe and like. And goodbye.